didn't finish this problem, but we kind of started it about overweight, right? 80% of all Americans, it says, by a Harris poll, says they're overweight. So if what would I expect? So if I randomly picked, so if I had the name of every single American in a big hat, and I picked the first one, picked the second one, what would the probability be? Or how long would I expect to keep picking until I reach someone who was considered overweight? About one or two, about the first person or second person. I would expect, oh, this person's overweight. Okay. Okay, so B says, what's the probability at the fourth person? Nope, nope, nope. Fourth person, yes. Okay, so that means I have one success. Geometric, you always only have one success. One success, geometric. Once I get the success, I'm good. I'm done. I move on. That means there will be 3 failures. So, not overweight, not overweight, not overweight. Last one is overweight. Okay. So when I multiply that, what do I get? 0.064. Another 0 between the 0 and the 6. So even smaller. So less than a percent. Less than 1% chance that would happen. Why is that so low? Why is that number so low?
Because there's a higher chance that the person is overweight. Well, if you're expected, if 1 or 2 people, like the first 1 or 2 are expected to be overweight, if it's the fourth person, it's going to be a really low chance.
Exactly. And as I keep going, I'm expected the biggest probabilities are 1 and 2. After that, as I get farther and farther away from 1 and 2, it's going to get lower and lower. So if this number was 5, 5th, 6th, 7th, this number is going to get even smaller than it already is. It's half of 1%, right? All right. Okay, so this one says it takes more than 4 people. More than 4 people. So 5, 6, 7, 8, 9, all the way to I get to every single last American. This represents the last American out there, right? So I got to start with 5 and count up, right? So I use my calculator. This is all the work I need to see for this problem. I'm good there. If you show me this work here, that tells me what you did. Okay? Then you just go to the calculator. And you say, all right, well, what's the probability of 5, 6, 7, 8, all the way to the last American? Okay. So let me get my calculator up and going. Okay. So the only thing about when you're doing these is no calculator. They don't want you to write down any on a paper. In your notes is fine. Notes are different. But like when you're answering questions, anytime you're answering questions, don't write any calculator lingo or calculator commands, because sometimes what you'll do, you'll have someone do this. This is what we're going to do. This is about what we're going to do, right? You'll have someone do this. 1 minus geo CDF n, or sorry, probability of success is 80%, and k is, we're going to stop at 4, right? You'll have someone write that. That's not statistics. That's calculator command, right? It's kind of like that's what you're telling the calculator to do. That's not part of statistics. So even though that's what you do, and in your notes is okay, it's not a bad idea to write that. They don't want this. Okay, so it's kind of not. I don't want to say frowned upon, because they will take off points if they see that, but yeah, you don't want it. You don't want to write that on a test or a quiz. Okay, you can write in your notes. It's a good idea. It's a good idea to do that so that you know what the commands are. But if we're doing it on a test or a quiz, especially, you don't want to write that those commands on there. Okay. All right. So So we're going to go second, VARS, all the way to the bottom, geometric CDF. Probability of a success in this case is 80%. The X value is going to be 4 in this case, because we want 0, 1, 2. Actually, there is no 0 because you're going to pick the first person. So for these, there are no 0. 1, 2, 3, 4, stop right there. And everything else is the answer I want. So for you. And look what happens. So that number is 0.9984. Pretty high probability. Can't get too much higher than that.
Shouldn't it be lower? Oh, then you subtract it by 1.
Then you subtract it by 1, yeah. Then you're going to have a lot of zeros. 0, 0, 1, 6. Yeah, I was expecting pretty low. That's low, but I was expecting some more zeros there. While we're talking about small numbers, while we're talking about very small numbers, I want to bring up something. So if you're using the calculator, I think Abby brought this up the other day. If you're using the calculator, sometimes what the calculator will do will give you an answer. If it's so small, it'll give you an answer in scientific notation. Like it'll do this. It'll say this. It'll say something like this. Let's see.
8.78977.
Yeah. What?
83 e to the negative 6.
Say it one more time. 8 point what?
8.789777083 e to the negative 6.
All right, we'll stop there. E, and then it says negative 6 like that, right?
Yeah.
That's scientific notation. So what that means is this. What that means is 8.789770 times 10 to the negative 6. That's what that means. Now, if we have a negative power, that makes the number smaller. So negative, we go to the left. Positive, we go to the right. So what you're going to do is you're going to move the decimal that many times in the negative direction. So you're going to go 1, 2, 3, 4, 5, 6, make a dot. Try it again. 1, 2, 3, 4, 5, 6, make a dot. And then you're going to have to fill them in with placeholders. 0, 0, 0, 0, 0. Now that number is pretty much what? It's pretty much nothing, right? But that's what it means. That's what that means. Sometimes the calculator, if it's so small, but it's not 0. This number is not 0. This number right here is not 0, but it's pretty darn close to 0, right? If that was the size of an organism, you would need a very powerful microscope to even see it. Okay, so instead of just saying 0, your calculator is going to give you that. So just know that was what it means. Most of the time, it's with the negative. It's with the small numbers. So you just move your decimal that many times to the left. Okay, if this is a positive number, then you're going to move your decimal that many times to the right. A really big number. Okay, that's all that means. Sometimes your calculator will do that. All right. Because your calculator is a calculator. It doesn't have a brain. If it had a brain, it would say, hey, it's pretty much 0. But your calculator doesn't have a brain. It does what you tell it to do it, right? So that's why it'll literally give you that. It'll give you what it is. Sometimes you don't want that. Okay. Okay, and then yeah, question D was the same as question A, just worded differently, but their answers are the same. Expected value. Okay. Okay, that's where we stop. Okay, so you guys are saying 80% extremely sounds high, right? Even if you're cynical, 80% is high. For the for So this is how they come up with it. I got this from my doctor's office.
Oh, wait, BMI?
Yeah, this is where they get the BMI.
BMI isn't exactly.
Well, that's where they get it from. That's what I'm saying. That's why I said this is garbage. It's because look you could be someone The healthy is a little too low, or is a little too. I'm pretty sure the green and the yellow should be probably more healthy, right? And yeah, it's just not. So when it says 80%, it's coming from BMI. And if you look at the BMI, yeah, most of us would probably be in the yellow or the orange or the red. Not too many people are considered healthy or underweight. Maybe you guys are because you guys are young. Your metabolism's pretty fast. But adults, it's yeah, it's not exactly. Exactly. A lot of a lot of these people over here who are considered obese are extremely healthy. They're healthier than any skinny person, right? They're just built differently. Bone density.
Great wording choice.
They're just, what like Kuldeep said, bone density and stuff like that. So that's where the number comes from. So is it a little high? Yes, it's a little high. That's not to say that the obese percentage in the United States isn't high. It's higher than it should be, but that's why it's so high. Okay. You guys are the first class to say, every class that I always have sees that number and they're like, whoa, that's way too high. I'm like, you're right. You guys are the first class to say it's too low. Yeah.
Oh, you man.
Okay, so last thing, very last thing. So before we get to the last thing, the last slide, the last part of it is your calculator commands. This is the calculator commands they don't want to see. So anytime you're answering a question, in your notes is fine. That's why it's in here. It's in your notes. But any question you answer and you're going to turn in for someone to grade, they don't want to see these commands, right? This is what you do on your calculator, not what you write down on paper. Okay, but that's how to do it.
Can you like write it down like before the test, just to like keep it fresh in your brain? So if you get a question like that, you can.
Yeah, like I said, it's good to write down. It's always good to write down this stuff here because it's good so that you remember it. And I'm not even saying don't write it on the test, but after you've done it, erase it or cross it out. That's a great idea. Do this. You don't even have to erase it. You just do this because anything you cross out, you're not allowed to grade. You're not allowed to grade anything that's crossed out. On AP, anything that you've crossed out can't be graded, whether you want to or not. Whether you're like, I want to grade that. That's the right answer. I can't. If it's crossed out, I can't look at it. It's not there. So if you want to do that on a test, like write that down and then just do this or do this, then perfect. You're not allowed to grade it if it's crossed out. Okay, let's get back to the last question. All right, so a well-traveled highway has traffic lights green for 82% of the time. So there are some highways that have traffic lights. 41, if you're driving to the coast on 41, right when you get out of Fresno, there's a lot of lights until you get to 198. And then once you cross 198 and head toward Kettleman, the lights go away. But yeah, some of them do. Okay. So a well-traveled highway has its traffic lights green for 82% of the time. If a person is traveling the road, goes through 8 traffic intersections, complete the chart to find the probability that the first red light occur on the nth traffic light. So whatever we're looking at. For example, if I'm driving on this highway and I drive through a light and I'm coming up to a light, there's an 82% chance that light's going to be green. Okay. I cross that one. Whatever happened, doesn't matter what happened. I go to the next one. There's an 82% chance that light is green. Every light I run into, there's an 82% chance that it's going to be green. So that means what percent chance it's going to be red? Red. We call it, if you cross it. So we're don't worry about yellow because yellow. If you stop, it's red. If you go through it, we'll call it yellow. Okay. So what percent of the chance would you stop? 18%. 18%. So in this case, 82% is success, right? I safely cross through, 82%, right? If you cross through on a red, that's not safe. So cross through on a green or a yellow safely, that's 82%. Okay, stop with a red or yellow and then red, that's 18%. Okay, so what is the probability that I go through the first one and I get a red light? 18%, right? The probability that I got a red light on the very first light is 18%. 18%. 18% chance that the first light I come to is red. Got to stop. Okay. The second one says, what's the probability that I pass through the first light safely, and the second light is the one I have to stop at? Okay. So what happened on the first one? I went through. What was the probability that I went through? 82. 82% that I got through. And then I have to stop on the next one. What's the probability that I have to stop? 18. So, right? So it's kind of like it's a tree diagram, right? But we're literally stopping the tree diagram whenever we get a red light. So in this case, success is a red light. So green, red, 82%, right? There's a 18% chance that I stop at the red on my first light. Okay? And then here, let's say I didn't get a red. I didn't get a red on my first one. On my first one, I got a green. Red is success. That's when we're stopping. Why is red success? Because that's what the question asks. We don't determine what is success and what is failure. They do. Question A says right there. First red light. First red light. They determine what success is. They didn't say first green light. They said first red light. So that's success. So success in this case is a red light. So what's the probability that I go through the first light safe, got a green light, and then the second light I have to stop at? So that's going to be, so the probability of 2, second light being it, right, is the first one I got, 1 failure, 1 success, right? 1 light I passed through, that's failure. 1 light I stopped at, that's a success. So when I multiply those, what do I get? Say it again, Josh. Okay. Let's do 3. What's the probability? First light, failure, I went through. Second light, failure, I went through. Third light, I get my first success. So I had 2 failures, 1 success. So keep doing that until you get to 8, because there's 8 lights total. What's the probability that on the third light, that's my first red light? On the fourth light, that's my first red light. Keep going all the way. Just fill out the top. Fill out the top here. All of these. Mm-hmm.
So, should it, like, look, I'm looking at the equation, it says that K goes above the probability. So should, but K is like 2 and K is 3, so shouldn't that 2 be squared?
Which one?
Or shouldn't the 1 be a 2 and the 2 be a
Yeah,
3?
so the way it's written on the should be like that. Oops, let's see.
You're saying that because it's x equals 3, it should also be to the third power.
Yeah.
So it's not because this is the probability. Yeah. So we're doing 3 triangles, right? And then we're trying to find the probability that we get 1. So like the first one, we're doing 2 trials. but we win one, so that's why 0.18 is the first power, and then the other trial we fail, so 0.82 is one as well. And in this case, it should be the exponent should equal what's inside the p.
Yeah, exactly like Aldrin said. This is the total number of lights we've gone through, right?
How are you supposed to know when to follow the equation and when to not?
So I am following the equation here. Let's see which one. Let's see here. Let me go back up.
No, that's the right thing.
Are you looking at this one?
Yeah.
All right. So probability of success here. So for this question, the probability of success is 18, right? So I'm always only going to have, oh, I see what you're saying.
The way it's written out.
I see what you're saying. Yeah, that's not a good, yeah. No, yeah. That's a typo. This should always be 1 because success you're only going to have 1 of.
Okay.
Yeah.
Okay. So that makes more sense.
Yeah, we all had trouble.
Okay. Thank you.
No, yeah. That's a typo for sure. I think I cut and pasted it and forgot to take that off. You're only ever on geometric, you're only ever going to have 1 success. Everything else will be a failure. So this one should be, yeah, this one is wrong too. This one's going to be k minus 1. Whatever k is, take away 1. Yeah, no, for sure. I've never seen that. Yeah, I've never. No one's ever brought that up, but that's right. No, it's not correct. Yeah, no, for sure, it's not. Yeah. Yeah, let me change it on my notes too. So, first success means there's no failures, just 1 success, 0.18 to the first power. 2 second one means 1 failure, 1 success. 0.82 times 0.18. On the success on the third one means 2 failures. So 0.82 squared times 0.18. And you keep doing that until you reach 8, because that's how many lights there are. Okay. So the probability that I don't get a red light until the last light is 0.449. Yeah.
I have a question. Okay,
Yes.
so I did it like just on the calculator doing like 0.82 times 0.18,
Mhm.
and I got those answers. But when you do it with the like geometric
Mhm.
PDF thing, you get like a complete. Well, at least I'm getting like a completely different number.
So you did for like each of these you did a PDF?
Yeah, I tried to.
Let's take a look. Let's see here. I got my calculator right here. So, oops, right there. So let's see. Let's do the second one. Let's see. So you're gonna go. This is a PDF because I only want 1, right? So PDF. So there's 0.18 is success, and we're gonna do 3 or 2. Let's do 2.
I had my 82 and 18
Ah, there you go. Yeah. Sometimes it's confusing. Which one's success and which one's failure? Because you think green light is success, right? But in this case, it's the other way around. How do we know? Because that's what the question wants. First red light. So that means success is there. Success is 0.18. Okay, yeah, that'll tell you. Yeah, so just make sure, read it through, and that'll tell you which one's the success is and which one's the other one's failure. Okay, cum probability. Cum just means you're adding them up, running total. So you can use CDF, geometric CDF, or you can just add as you go. So 0.18, so this one's going to be 0.18. The next one is what I already had plus what I have now. So 0.18 is what I already had plus what I have for 2, 1476. Okay. Plus what I have for the next one. Plus what I have for the next one. Seven, 8. Plus what I have for the next one. Plus what I have for the next one. Plus the next one, 0.547. .0449. Okay. So the probability that I get a red light less than or equal to 8 is right underneath it. So less than or equal to 8 would be this number here. Less than or equal to 1, or sorry, 2 would be this number, and so on and so forth. Okay. All right. And that's the end. Okay. That's the end of the notes.